and welcome to the 8th episode of Dev Show. My name is Sherry Liz, and I'm your host today together with my good colleague Rasmus Jack. As usual, we planned an exciting hour show for you, which Rasmus is going to talk about it slightly later. And one thing I want to mention that you get an opportunity to ask your question from the speaker as well later on. And how? Doesn't matter if you're watching us through Twitch or YouTube, you can type your question and ask it from the speaker, and the speaker is going to answer that during the Q&A, which is going to be after the talk. And you can use the same chat functionality to let us know where you're from as well and from where you're watching us, and even give us your feedback. But one thing though, that when it's about the typing the question, even though that we are an online community, we really want to have and create an inclusive environment for everybody. So when you're typing the question or the comment, please have in mind that make sure that your comments should not make anybody offended. And I really encourage you to familiarize yourself with our code of conduct, which is highlighted, thank you Rasmus, on our meetup page. Okay, and other thing is that all of you are going to get an Azure Heroes Learner Badge. And I'm going to talk about that later on, but the Learner Badge is like a token of appreciation from Microsoft to all of you to learn our technology and use our technology later on. We're going to actually post it in the chat as well, and that how you can get it. But at the end of the show, I'm going to show you a QR code where you can scan that. And Rasmus, so what do we have on the agenda for today?
Yeah, we have an interesting topic. So the session is called Machine Learning in the Browser with TensorFlow.js. So then you could ask what's going to be shown in the session like that. So the topics from the speaker today is what is machine learning, introduction to TensorFlow, why TensorFlow.js, and then you're going to be showed a couple of demos together with some real life scenarios. So that's going to be really interesting. And today we have a great speaker, and it's Håkan. And Håkan is a manager of AI and big data of a company called Miles in Norwegian, and it's a consulting company. He has over 20 years experience working as a consultant, and previous to that he worked as a human machine interface and process automation and robotics. Long sentence, but interesting. He have also a mixed background both in technology and psychology, and he likes to work with how we can make technology easier for humans to use. Really interesting and important topic right now. He's also the chairman of the Norwegian.net user group and one of the co-founders and organizers of the Oslo AI meetup group. And during the past 2 years, he has tried to share his knowledge by presenting at conferences and meetups, and so far he actually done over 40 presentations in Europe, USA, and Africa. So you might already have seen Håkan present some of his great knowledge to the community. So welcome, Håkan, to the Dev Show. It's a pleasure to have you here.
Yeah, thank you. It's really exciting to be here. I've actually seen, I think, almost every show since you started, so I really like this format.
Okay, another great friend of the show. Thanks for that. So yes. You said that you have met some famous people. So let's see if Sherry can guess who that might be. So you get 3 options, and it could be more than one. Sherry, just have that in mind. So one of them is Magnus Carlsen, the world chess champion, and the second one is Jens Stoltenberg, the Prime Minister of Norway from 05 to 2013, and the third one is Morten Harket, the lead singer of a-ha. And now don't start saying Sherry, but so let's see if you can guess. And I don't know it either. So Håkan, you need to jump in here and see if
So
she's.
can I use machine learning to help me to get? I mean, since I have multiple options, I would just say that how about that you met all of them?
That's interesting alternative. What do you think, Rasmus?
I think definitely Morten Haget. So and talking about the topic here, it could also be Magnus because chess and AI and yeah. So I say Magnus and Morten.
Actually, Sherry is the one who has the right answer. It was all three of them.
Nice. Any words you want to attach to that? Have you been singing with Morten or?
No, not really. I suppose he was probably with his granddaughter out on a 7-Eleven store and buying some ice cream. And with Magnus, he was buying some smoothie or something in a smoothie store. And the previous Prime Minister, Jens Stoltenberg, I just saw him, on the street, just walking like a regular guy.
Nice.
Exciting.
Okay, good stories. So let's not drag it out and let's go into the topic of today, Håkan. So I will just, or we will just give you the stage and step in the background. So take it away. Look forward to hear the session.
Okay, so thank you very much for coming here to my talk. So I'm going to talk about machine learning in the browser with TensorFlow.js, and I'm going to be showing you some demos. So as we said, I work as a manager for AI and big data for a Norwegian consultancy company. And I think we've actually covered my background already, so I will skip this slide here. But this is the agenda here for tonight. So first of all, I'm going to be covering a little bit about the basics about machine learning, what it is, so that everyone is sort of on the same page, so that we can understand this topic much better. Then I'm going to go through the basics of what is TensorFlow, and then we will concentrate on TensorFlow.js. So we'll have two demos if the time allows. So one demo we will write an application actually from scratch in JavaScript, and then we will use the TensorFlow.js and have a look at what can we actually do with TensorFlow.js more or less out of the box. And then in our second demo, we will make use of an already existing machine learning model, which is called ImageNet. So the ImageNet is used in order to classify images. So we're going to have a look at how can we make use of such a model inside our web application. But the first thing here is, what is machine learning? So, there's a lot of hype and discussions about machine learning and AI in these days. So maybe you think that machine learning must be something really new. But the matter of the fact is that machine learning dates back already to the end of the 50s. So there was a guy called Arthur Samuel. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And another description here is that machine learning is sort of a pattern recognition in historical data. So we'll have a look at what that actually means here in a while. So some applications here of machine learning is, for example, prediction. So a classical example here is that you have a number of house prices, and you want to predict what will a new price be for a new house in a new location. So then you have some features, which could be, for example, the number of rooms in the house, and it can be when was this building built and in which neighborhood it is. So then we can try to predict a new price based on the historical data. You can also think about recommendation system. So maybe you have an online store, and based on previous historical purchases, the recommendation engine will propose or recommend things that you probably are interested in. You can also think about clustering. So say you have a huge amount of customers, then you probably want to divide these into different clusters so that you can target these much more directly with for example, marketing or campaigns. And also you have maybe more traditional like image recognition and text recognition and speech recognition. So one flavor of machine learning is called supervised learning. So the basic idea here is that we have access to historical data, and we also have access to the historical output from this data. So by using this, we can build a machine learning model. So we can train up a model, and then we can use this model in order to make use of real-time data. So this new train model can take new data, and then it will output. It could be a prediction, or it could be a recommendation, for example. So this is what we will do in our first demo in a short while here. But as I said here, machine learning is really nothing new. So the question is, why is there such a huge interest in these days for machine learning? So there's a number of enabling technologies. Some of them is that now we have access to cheap sensor technology, so that we can get lots of data, and we also have big data technology, so we can do extraction and load and transform work, and we have machine learning algorithms that we can run in the cloud, so that we also get lots of scalability. And for us as developers, the good thing is that all of these are exposed through API and services that we just can make use of. And just for completeness sake, I should also mention that even though we can actually do machine learning in any type of language, we don't really want to start from scratch. So two of the most popular languages, due to that they have lots of libraries that we can use, is Python and R. And traditionally, Python has been more popular among people coming from a computer science background, whereas R has been more popular among people from a statistical background or coming from academia. So now when we've covered some of the basics about what machine learning is, we're going to go more deeper into TensorFlow. So the first thing that we need to figure out here, what is TensorFlow? So TensorFlow is an open source library that was developed by the Google Brain team, and it's expressing its algorithms using something called tensor operations. So I'll go more into what is a tensor in a short while here. But the main thing here is that TensorFlow supports distributed computing. And this is a really big advantage if you're going to run, for example, neural networks, or if you're going to run deep learning. But then you might think here, what is tensor? So tensor is something coming from mathematics. So in mathematics, you can say that either we have a scalar, which is a real-time number, or you have a vector, which is a collection of numbers, or you have a matrix, which is like a two-dimensional collection of numbers. And then you have something called a tensor. So the tensor is actually just a collection. So in this collection, you can store either scalars or vectors or matrices in a tensor. So so the tensor format is important here in TensorFlow, because that is sort of why it has its names, that it only works with tensor. So if you use regular TensorFlow in Python, this is an example here where we import the TensorFlow library as TF, and then we can start up a new TensorFlow session, and we can define two constants. So we define a constant A, which has the value of 10, and the B with the value of 32. And then we can just run a simple addition here and print it out on the console. But the topic here for tonight is TensorFlow.js. So TensorFlow.js, it's a JavaScript library, so that we can both train and deploy our models in the browser, and also using Node.js. So the advantage of this is that then you don't need to learn a totally new language, Python or R, and you don't need to learn about Jupyter Notebooks or these types of tools. You can just use the web development tools that you're already accustomed with and that you like to work with. So that brings us over into our first demo here. So let me switch over here to the browser, or actually I can switch over to Visual Studio Code. So the first thing that we need to do now, if we want to use TensorFlow.js, is first we need to get access to this library. And in this example, we're just importing TensorFlow.js through a CDN, but you can also import it through either NPM or Yarn or other related technologies. And we are also using a second library here, which is called TensorFlow.js visualization, and that's a visualization component that we will quite short have a quick look at what that actually is. And then we have our script file, and so far we're only writing out on the console log hello TensorFlow, just to make sure that our that our file is actually running. So if we switch over here to the browser and then we run this, then we can see that we get the hello TensorFlow. And we can also see if we write TensorFlow.js. Let's see. If we write TensorFlow, then we can see that we have access to our library. So that is, it has been loaded. Okay, so that's a good starting point here. But then, we also need to have a problem that we want to solve. So one of the things that we need to have access to is data. So luckily for us, we have access here to a file. It's a JSON file here with lots of data about different cars. So for example, we have information about the car name and model and the miles per gallon, the numbers of cylinders and the horsepower and so on. So what we would like to find out here is, can we use this data and can we use it to predict a new value here? So let's take two different things here, like for example the miles per gallon and the horsepower. So first thing that we want to find out, is there some sort of relation between these two things? And if there is a relation, can we build a machine learning model so that we can predict one value from the other? But the first thing that we need to do here is to actually load this data into our application. So if we switch over here to Visual Studio Code, then we define a new function here, which is called get data. And what we do is we just fetching the data, our cars data JSON file, and then after that we are cleaning it up a little bit. We just extract the data that we're interested in, which is the miles per gallon and the horsepower. And then we filter out the null values because we don't want to have any null values in our data. But then we also need to have a function here so that we can run this thing here. So let's define a function we call run. So in this function, we are calling our get data function, and then we map our data so that we have on our x-axis, we have the horsepower values, and then on our y-axis, we have the miles per gallon. And then after that, we're actually using this TensorFlow visualization component in order to render a scatter plot. So we will have a look at what that is. But the scatter plot is actually so that we can see, is there any sort of relation or correlation between the horsepower and the miles per gallon? And then we're just adding an event listener, so when the DOM is loaded, it will run this function. Let us save this, and then we switch over here to our browser, and we select the right tab. So here you can see one of the strengths here by using this TensorFlow visualization component is that now without having to add almost any code, we were just using some configuration for our visualization component. We get here a scatter plot of horsepower versus the miles per gallon. And what we can see from this plot is that it seems to be that there is some sort of relation between horsepower and miles per gallon. And that's a good thing, because if our data points would have been scattered all around the plot, that would have meant that there is actually no relation. So then we can't really use machine learning, because the machine learning, there's no relation, there's nothing to learn for a machine learning model. But now when we have a look at this plot, we can see that this is a good starting point. There seems to be some relations, so then we can use machine learning in order to learn this relation. And and then we can make a machine learning model in order to predict new values here. So the goal here is that we want to be able to train a model where the input is the horsepower and the prediction is the miles per gallon. So what we'll do is we will use these values, and then we will feed them into what is called a neural network, which is one form of machine learning here. So this neural network will learn from these examples that we have here. So then after that, it will be able to predict miles per gallon from a new horsepower value. And this is an example of supervised learning that we were looking at in my PowerPoint slide there. So the first thing that we want to do now is we want to define our machine learning model. So in plain words, that is an algorithm that our model should use in order to be able to compute these answers. So in machine learning terms, these models, they are an algorithm that take an input and then it produces an output. And in this case, we will use a neural network. So here the algorithm is a layer of neurons with different types of weights. So they will decide what the output is. So we'll use this data that we have to train our model, and then our algorithm will learn the best values for these weights in the neural network. So let us add a function here to our code in order to create the model. So here we are defining a model that is called TensorFlow sequential. So this is one of the most simple models that we can have in TensorFlow. And it's called sequential because it's a straight flow here from the input down to the output. And of course, we can also have much more complex models where we can have multiple input and multiple output and different types of branches in our model. But in order to keep it a little bit simple here, we choose this sequential model. And the first thing that we do is we need to add a layer here to our model. So we add an input layer, and we call this a dense layer. So dense layer is a type of layer that multiplies its input with a matrix. So these are these weights that I was mentioning before. And then it also adds a number that we call a bias to the result. So this is the first layer of the network. So we need to specify the shape of the input, which is, in this case, it's 1, because that means that we only have one number as an input, and that is, the horsepower of the car. And then the unit sets how big will this weight matrix be in the layer. So here we also set it to 1. So that means that will be one weight for each of these input features. So right now we only have one input feature here. And then we create an output layer where we also set units to 1 because we want to have one number as our output. So the things that we need to do now is actually to create an instance of our model. So let's add some code here to our run function in the script. So if we scroll down here, so what we do here is we create the model using this function that we just defined, and then after that, we're using our visualization component in order to show some information about our model, just to check that it seems okay. So let us save this, and then let's switch over to the browser, and we run this. So then if we scroll down, then we can see here that we get the model summary. So we can see that we have two layers, and we have the output shape and the number of parameters, and that it's trainable. So we didn't need to do anything in order to get this model summary. We were just calling a function here on our TensorFlow visualization component. So that's also an added benefit of using that component here. So the next thing is that we need to prepare our data for training. So as I mentioned, TensorFlow is called TensorFlow because it works with tensors. So that means that we need to convert our data into this tensor format. So while we're doing that, we will also use some best practice within machine learning, so that we will be using something called shuffling and also normalization. So let us add a function here to our code. So over here. So basically what we are using here is that we get our data in, which is this JSON file, and then after that we want to convert our data to the tensor format. But before we do that, we are using a function called shuffle, which is also part of the TensorFlow library. And the reason for that is that when we do our machine learning training, we will divide the data into batches or into subsets of the data. So when we train our machine learning model, we want these batches to be as representative as possible for the whole data set. And that's why we would like to have data from all across the data distribution. And the reason for that is because if we do this, then we minimize the risk of that we will only learn things that are dependent on the order of the input data, because now when we are shuffling the data, the order doesn't really have any input into this. And the second thing is that we don't want to be sensitive in, there can be different types of structure in subgroups of the data. For example, it could be that we have a high amount of horsepower for the first half of the training data, and that's a relationship that is not representative for the whole data set. But now when we are shuffling, we don't run any risk of running into that problem. So we then after that we convert our data to tensors using the TensorFlow Tensor 2D, and then after that we want to do something called normalization. So here we're using something called min-max scaling, and the idea behind this is that we would like to have our data to be in the range of 0 to 1. And the reason for this is that many of these machine learning models are designed to work with numbers that are not too big. So that's why we're doing this normalized input and the normalized output, which is in this case is called labels. But we're also saving this input max and input mean and label max and label mean, because when we're through with all of this, then we would like to be able to convert the output from our machine learning model to the same scale as we had from the beginning. So then we need these values in order to do a conversion. Yes. So the next thing that we would like to do is we would actually like to train our model now that we have it in the right format here. So let's define a function that is called train model. So the first thing that we need to do is we need to compile our model before we can train it. And we also need to set some parameters. So we set an optimizer. So the optimizer is actually the algorithm that will decide on how we should update our model as it sees the new examples. So there are lots of different optimizers available in TensorFlow. And here we've just picked the add-on optimizer because it's quite effective and it requires very little configuration. And we also need to define something called a loss function. So the loss function is sort of a quality measurement. So it will tell us how well is our model performing on each of these data subsets or batches that is shown. And we also can use something called the mean square error. So with the mean square error, we can compare the predictions made by our machine learning model and actually with the true values. So we want this to be as small as possible. And the last thing that we need to do is decide upon a batch size. So the batch size is how much data do we want to have in each subset. So some standard batch sizes is between 32 and 512. And there's no ideal batch size for all problems. So deciding on the batch size is actually a science in itself almost. So we'll just take a regular batch size here of 32. And then the epochs is the number of times that our machine learning model will look at the entire data set. And here we set it to 50, so that means it will take 50 iterations through the whole data set. And then finally, we will start this training loop with this return await model.fit. And then we're using this TensorFlow visualization component in order to be able to visualize on each epoch. We will make a graph here of our loss function and our mean square error. So next thing that we need to do is actually to be able to run this function here. So we add some function here to our run function. So what we do here is we convert the data to the TensorFlow format, and then we extract the input and the labels, and then we train our model using our inputs and labels and our model. And then we write out on the console log when we're done with the training. Let's switch back over here to the browser here, and we run this. And then if we scroll down, so if we scroll down here, we can see here our loss function and our mean squared error that we are monitoring. So on the x-axis, we can see the number of epochs, so it goes up to 50, and then we want to have this value as low as possible. So now we can see that it's done training. So the next thing that we want to do is we want to actually use our machine learning model to make some predictions. So we will add a function here which is called test model in order to test our model. So let me add this thing here to just do the code. So what we are doing here is we are generating using also TensorFlow method there, linspace. So we're generating 100 new examples that we want to feed into our model, and then we will get a prediction out of our machine learning model. So in order to get these predictions, we can only call the model.predict method using this input that we just generated here. And then, as I said, we want to be able to scale things back to the original scale. So that's what we're doing using this input max and input mean and label max and label mean. So by using this, we can get an unnormalized data. And then finally, we are returning this unnormalized data to the calling function using a function called data sync. Yeah. And then we're also using our TensorFlow visualization component here in order to render a new scatter plot so that we can compare it with what we actually had in our original plot with this new data and see how it performs. So then we only need to add some code here to our run function. Now in our run function here, we're only running this test model with the model data and this tensor data. And if we run this in the browser, like this. So now I should also say here that, now we're also doing this training for each run here, but that's just, that this is just an example. So if this would have been a more real world or live example, we only need to do, the training once, and then we can monitor our machine learning model. So if we see that it deviates a lot, then we need to do retraining of our model. But, you don't need to do this training for every time you run your machine learning model. But now this is done training. And then we can see here, so this was our original data, which is this blue dots. And then this is our prediction, which is this orange straight line here. So yeah, so that shows us a little bit about what we can do here in the browser. So some of the strengths here is that we're using both the TensorFlow library, which had many different types of methods and functions that we could use, and we could also use this TensorFlow visualization component in order to do some plotting of our data and also do some monitoring of our data and so on. So it's quite flexible. We didn't need to write a lot of code. So, but we get out quite a lot of functionality out of the code that we wrote. So with that, I will just go back here to my presentation here. But in addition to start from scratch, we can also use existing models because there's lots of existing models that we can use. And maybe you have, maybe you're working in a company that has its own data science department, and probably they are generating lots of machine learning models in Python, and maybe you want to like to use them in your web application. So what you can do is you can convert a model. So for example, I will give you an example here of how we convert a model which is in a format called H5 to the TensorFlow.js format, which is called a layers format. So that the way that we can do this is we can use our command prompt or our bash, and then we can just issue a command here, TensorFlow.js converter, and define the input format, which is in this case is keras, and then the path to our H5 model, and also the path where we want to have our output. Or you can also use it in Python. So then you use this code, you import keras, you import the TensorFlow.js and TensorFlow. and then you load the MobileNet model, and then you use TensorFlow.js converters save Keras models as something. And then in your JavaScript application, you can import TensorFlow, and then you just load the layers model by referencing to where you have saved this model. So that brings us over here to our second presentation here, or our second demonstration. So in a second demonstration, we are actually using this. So I've done this thing here. So I converted Keras H5 model to the TensorFlow.js layers format. So we're actually using this MobileNet, which is used to do an image classification. So let me show you first how this is done here. So we can select the file here. So we can select this thing here. And then we can select a model. So in this case, we select the MobileNet model. And then we do a predict. And then we can see here that our MobileNet model is predicting that it's a 99.95% probability that this is a strawberry, for example. So then the question is, how much code did we need to write in order to do this? So let me switch over here to Visual Studio Code. So so basically, here is the code for the GUI where we have the buttons for loading our model and selecting our model and loading our image and so on. And the interesting thing here is that here we are, again, we are referencing a CDN with the TensorFlow.js library, and we also have two JavaScript classes. One is called ImageNet classes. I will show you what that is soon. And the other one is where we're actually doing the heavy lifting here, which is called predict. So let's go into the predict JavaScript file. So in our JavaScript file here, this is the change event selector here when we select an image. So we load our image here, and then when we select a model, we call this load model function using this name. So one of the name was ImageNet. And then what we've done is we have a directory structure here on the left. So it will go into this structure, TensorFlow.js models and MobileNet. And this is the files that you get as a result of this conversion command that I did previously. And here we get our model JSON. So it will load this model JSON, which is our MobileNet model. And then when we click predict, it loads the image, it loads the model, and then we need to do some pre-processing of the image just to make sure that it's in the right format, that we get the data into the right types of shape and into this tensor format. Then when we have it as a tensor, then the only thing that we need to do is call model.predict with our tensor, and then we can call data to get our predictions. And then we're just taking the top 5 predictions from our result, and we write out what is the probability and what is the class name. So now out of the box with the ImageNet, you will only get an index here as the class name. So with this index, that's why we have this ImageNet classes file. So here we just do a mapping here from the index to the textual value. So basically, so that's all we needed to do in order to use this very powerful ImageNet model. So that's also an advantage here, that you can you're not restricted just to be able to train and build your model yourself. You can also use pre-existing models. So let me switch over back here to the presentation, and and then some arguments here. Why do we want to use TensorFlow.js? So one of them was this thing that you don't need to learn a new language, Python or R, but maybe another important thing is that you don't need to have any round trip between the client and server, because right now everything is done on the client, as you can see from this example. And that also has the added benefit that the user data is local, which can be good in terms of security. You're not risking that you will have a man-in-the-middle attack, for example. And again, you use the browser, which everyone is used to use. So you get a UI which is highly interactive and easy to use. And you can also have easy access to your sensors, to your webcam and your microphone, and maybe to your gyroscope. And you can take advantage of your GPU. So now finally, I will just take up a couple of examples here from the real world. So one of them is from Uber. So Uber has a tool they called Manifold, which is a visual debugging tool that they use internally, which is using TensorFlow.js. And another example here comes from Airbnb. So they are using something called identity document detect. So this is used when you load up, identification documents to Airbnb. They will alert you if there's any type of sensitive information in the picture that shouldn't be there. And then the final example here is from the world of music. And this is quite interesting. So I advise you to have a look at it. It's called Magenta. So here we're using machine learning models in order to generate music. So you have AI in order to do music generation. So finally, here I have some references here. So one is the official TensorFlow.org page for TensorFlow.js. And the second is an excellent course from Coursera, which is called Introduction to TensorFlow. And then if you want to know more about this ImageNet example that I showed you, there is a YouTube series which goes much more in depth about this that is called Deep Lizard. So you can have a look at that from this link here. So with that, I would like to thank all of you for tuning in and listening to my talk. And if you want to reach me, you can either follow me on Twitter, where my name is Agrevlis, or you can write me an email. So so with that, I just want to thank all of you. Thank you so much for listening.
So thanks, Håkan, for this great presentation. You talked about the Uber case. Do you have some more insights to what they basically do with TensorFlow and what they do with this particular case?
No, not really, not more than
No.
that. They are just using it to be able to visualize and to do debugging, and probably they're using probably historical data to see if there are, maybe there are some faults that appear again and again, and maybe you can see like a root cause for these faults, so that maybe you can predict that now there will be a bug in this code because it looks very similar to what it looked like previously, for example.
Okay, super. So I see from the chat window that we don't have any questions. So you're still in the audience. You're still able to ask the questions if you have some questions for Håkan, and also of course after the session we will monitor the chat and we can follow up with the answers in the follow-up email that's going out afterwards. So don't hesitate to put in questions.
I can also mention here that, for those of you who might not be so interested in JavaScript, there's also a version of TensorFlow, which is called TensorFlow Lite. So with that, you can build native applications using either Android or iOS, and you can run that you can run it both on phones, but also on smaller systems. So that could be one option to look into if you want to further explore this thing.
Yeah.
And I also think that also another added benefit is that now we can sort of democratize machine learning to a whole new set of developers, all these web developers that maybe have been very interested in machine learning previously, but they haven't really, there's like a hurdle that you need to overcome if you're going to start using R or Python or, Jupyter Notebooks and stuff. But now I think that this makes it much more accessible. And also with this added benefit that you don't need to do something from scratch either. You can make use of this already made models that exist. So you can just sort of plug it into your application.
Yeah, I can actually relate to that very, very much because I'm coming from totally that background, and I can tell about from my experience that it was so easy actually to plug in with the TensorFlow and then to kind of to TensorFlow.js and then work with that. We did I attended to a workshop. Actually, it was with the TensorFlow.js team, and that I attended to that workshop, and it was so easy that with a kind of a couple of line of code, what we could do is that we wanted, if when it was, for example, the music was playing, if we just make a special gesture in this time, in this way, then the music would go up and then with volume down. And we had a cursor that when we just make a noise, two, it would go right, one is go left, left. It was so easy. And with this few line of code, as a front-end developer, you can add a lot to your to your application, and then make it more intelligent, you can say. And I have actually one other question for you, Hakan. That so yeah, can you tell us that I mean, what are the other the benefits of bringing all this down to the browser? And can you tell us that when are the scenarios that you should use, you should actually have all of this functionality within the browser?
Yeah, so I guess the biggest benefit is a little bit what you said, that is a much shorter time to get to market, and that it takes a lot less time to be able to prototype and to experiment and to innovate, because this is a lot more accessible than trying to do something similar in Python or in R, for example. But it could be, some of the limitations could also be, since you're running this on your device, it depends also on, what type of machine learning algorithm you're using, because if you have a really huge deep learning model, probably that would be much better off running it on the server. So maybe I should say that also. We never said that, but what you traditionally do is that you are running your machine learning model on a server, which has a lot of computing power, and then you expose it through an API, through, for example, a REST API. So so for example, in this example that we built, then what we would have done is we would have called an endpoint, and we would have put in the miles per gallon and get back the horsepower, for example. So but there are always these types of trade-offs. But I think the biggest advantage with using TensorFlow.js is this thing that I was talking about, this democratizing thought, that now all of a sudden all of this is accessible to a whole range of developers that has not been able to use it before, but now this is in reach for now this is in reach for you. So I think that's the best thing.
Yes, and I don't know, maybe you should correct me, because that I was just trying to to think about it, that also can be some added benefit of having an offline experience. Is it true?
Yes, yeah, that's true. Since we're doing everything here on if you can save the data that you want to have offline, and then you have your machine learning model is also running offline, then that's also an added benefit, because it's not everywhere that you can have access to internet or to to a mobile net, for example. So
Yes, that's totally true. I wonder to know that if still there is no question there. I mean, I also ask from the audience that if they use TensorFlow.js before. I see haven't got any answer. How about you, Rasmus? Have you used TensorFlow.js before?
I have heard about it and seen some use cases, but I haven't used it myself. So that's also why I'm a bit quiet here. But it looks really interesting, and I know it's also close to your heart, Sherry. So interesting topic, and I think I should definitely try to see what I can as a person also look into doing with the TensorFlow.js, definitely.
Yeah, I'm looking forward to see a talk from you, Rasmus.
Yeah. About TensorFlow.
Yes.
That I think it's better to invite Håkon back in that, or have it from yourself. Also, not to scare away the audience, but maybe on some other topics than TensorFlow, definitely. And speaking about topics for the future, we would definitely like feedback from all of you listening in and also watching it after the fact. So not watching live, but if you have feedback, if you have a topic that we should bring up in the dev show, and a particular speaker that you think we should contact and try to get on the dev show, and also, if you want to be a speaker yourself and have an interesting topic, please put it into the feedback form that you can go to with this QR code. You can also use the hashtag and write to us on Twitter or in the chat down here. So there is a lot of options depending on where you want to give the feedback, and also specifically for this session, we would like the feedback from your side as well. If you liked it. So yeah, Sherry.
Yeah, well, I wanted to say that now we had like an intro talk to the TensorFlow.js. So let us know that the kind of that what is the follow up kind of session about the TensorFlow.js that you want to hear. If there is any specific thing that you want to hear. I mean, I have some specific kind of that because I already talked to you, Håkan, that I want to work a little bit more with a face mesh to be able to whenever that kind of that there is a for example I made a demo the other day that we also showed it in the talk that when there is a I could analyze the face gesture. If there's a smile or something, then maybe I want to actually put the smile in some other kind of object or a dog who is standing there. So those face mesh they are so interesting to me. So and I would just say that this is of course this is like a very simple kind of that use case, but you can do a lot with those meshes that you can create. Yes, and yeah, we have actually Taras that kind of that telling us that yeah, they really like the demo and it's impressive. Thank you, Taras, for the feedback. And I would say that we can also. I mentioned to you all that to kind of that you can all get a learner badge from Azure Heroes kind of that program that we have. And stay tuned. Actually, tomorrow we are going to have a big announcement about Azure Heroes program during our Ignite session. But for now, that if you're not familiar with this program, this is a community program that we have from Microsoft to inspire you to learn more and use our technology, and also thank you for doing all of this, and also thank you for empowering others, because learner badge is one of the badges that we can have. But if you go to the Azure Heroes, I went to the wrong direction. uh, that Azure to aka.ms/azure.heroes, you can actually nominate yourself or a community friend for the other badges that we have. And yes, let us also know that what you think of Azure Heroes. You can follow the hashtag, and then you see that there what other people are talking about this program. I hope I go in the right direction. No? Okay. And speaking of upcoming events, Rasmus, what can you tell us about the tomorrow session?
Yeah, so you all probably know that this is Ignite week. So Microsoft Ignite is going on, and one of the sessions that you definitely should tune into is tomorrow, where Sherry and myself we will host an interesting session about the importance of the community. So for all developers and infrastructure related people, this is a great session to learn about how to become a community leader, also how to just be part of a community, what you can benefit from being part of communities, also like this dev show. And also we have had some interviews, right, Sherry? I've been spoken with Lars from Corti.ai about an interesting AI project that can save lives, and also talking to Ulrich from Trackman about how they can unleash the potential of athletes around the world in different sports. So you also talk to someone and that is gonna share something on the show.
Yes, I talked to the people behind Hack Your Future project, Radio School project, and also Wonder Coders project. And you can watch them all tomorrow at 2:45 Copenhagen time. And you can register for aka.ms/ignite-denmark. And as I also told you that we will make some announcement tomorrow about the Azure Heroes program, which is exciting.
Yeah, look forward to that.
Yes, and there is another you might have heard of Hacktoberfest. During the whole October, there are a lot of kind of that possibility for you to contribute to all the open source projects. And if you go to contributing.today, you can see that this is one of the Hacktoberfest meetup that we are also part of it. And there are a lot of interviews with all the interesting open source contributors or maintainer or creators, which telling you that how you can contribute in this project that you are most probably using, such as Git. There are a lot of JavaScript libraries there, PHP, all the open source projects that they are there, and you can find out how you can contribute to that. Really looking forward to see you all on October 2nd. And
and last but not least, we have some other sessions. As you heard last time, we have the workshop as a follow-up for Göran sessions last Tuesday. Go in and register for that. That's on the 28th. And then the next speaker on this dev show is going to be Vakas, talking about how they empower engineers within Maersk with self-service infrastructure by code. And also the 6th of October, adapting the PVA in the new world of dual screens devices with Kenneth. So also a really interesting topic to learn more about. And with that,
yes,
I think we are at the end. So if you have questions, if you want to reach out to us, you can ping us on Twitter. And I think it's only back to saying thanks for today, Håkan.
Yeah,
and
thank you.
thanks for being on the Dev Show.
Yes, we really want to see you again.
Yeah, thank you so much.
Yeah.
And thanks everybody for watching in. See you next week.
See you next
Same
week.
time.